Hello and welcome. In this video, I will discuss about the hardware requirements to build our own self-driving car. I will start in topology manner. So first of all, we need some kind of robocar chassis kit. I bought this chassis from Amazon because it is very easy to use and very easy to assemble. Now in this robocar chassis kit, we have 4 DC gear motors. And the gear ratio for these motors are 1:50, and this motor operates between 3 to 6 volt. Next we have 4 non-slippery rubber tires, and it is very easy to assemble these gear motors with these tires. And in the same way you can also deassemble very easily if you want. Next we have 2 transparent plastic plates. On these plastic plates we will mount all of our component. On the first plate we will mount our power source, and on the next plate we will mount all of our components. At the last, this includes the spacers and bunch of screws to assemble this chassis. Next we need some kind of motor driver to control all of our DC gear motors. For this task, I will use L298 dual channel H bridge, and this H bridge can control 2 motors at a time. This one has 3 headers. On the first header we will connect our first motor, and on the second header we will connect our second motor. Now at this 3-pin header I will connect my power source. This component can handle a voltage between 5 to 12 volts, but our DC gear motors can only handle 3 to 6 volt. So that's why I will use a 5 volt DC from my power source. Next component in my list is some kind of microcontroller to control this H bridge. For this task, I will use very common and versatile Arduino Uno board. I am choosing this board because it is very easy to use and a lot of people know about this. Now this is not a main microcontroller in our project. This will act as a slave device. This will receive the instruction from the main microcontroller, and according to the instruction, this will control our motors. Now we need some kind of power source to power up all of our components. For this task, I'm using 10,000 mAh power bank, but you can use any battery if you want. This power bank is capable to deliver 3 amperes, which is enough for our project. And also backup time of continuous operation of this project is up to 5 hours on this power bank. Now I will discuss about main processor unit, which will handle our image processing and also able to perform tasks related to our machine learning. For this task, you can use any 32-bit microprocessor board, but for this project, I will use my Raspberry Pi 3 model B+. This board has 64-bit 1.2 GHz 4-core microprocessor, which can easily handle 480 by 360 video stream for our image processing. Now make sure you select the Raspberry Pi with the Wi-Fi module, because Wi-Fi module is must to remotely control our project. Now next component in our component list is a camera module. For this task I will use a Raspberry Cam 2 with CAC cable. This camera module has 8 million pixels. I have already mounted this camera in transparent mounting case. With this mounting case we can easily mount this camera to our robocar chassis. This camera module has camera serial interface, and we will directly hook up this CAC cable to CAC port of our Raspberry Pi 3 model B+. Next we need some USB cables and jumper wires to connect all of our peripheral devices to our main microprocessor unit. Now at this point we are done with our second module. Now our third module is related to the machine learning. Third module, we will build our stop sign and traffic lights as a hardware. We will use these modules for cascade classifier training for machine learning. Now at the last, we need some additional equipments and components. We need some discrete components such as male headers, electrolytic capacitors, a 1555 timer, and bunch of LEDs. Next, we also need a breadboard for prototyping, a digital multimeter, solder, and soldering iron. Now this was the brief introduction about hardware requirements, and I hope you enjoyed this video. But if you have any question, then feel free to ask me, and I'll see you in the next video. Thank you.